everywhere in the shaft to be less than this 12 KSI. So that's what the maximum should be, or 12 times 10 to the third PSI. We'll find the minimum radius the fillet can be so that we're not going to have a stress higher than the 12 KSI anywhere in the shaft. I guess I'll add here, the smaller diameter is 0.75 inches. The larger diameter is 1.5 inches. All right, so the relationship we have when we have the stress concentration is that this value K for these torque problems is going to be the maximum shear stress over, we can use TR over J. In the case here, we're told that the maximum the shear stress can be is 12,000 psi. And we want to calculate what the average stress is, the average stress at the edge or at the circumference of that smaller shaft. We have a 710 inch-pound torque. The radius of the smaller shaft is 0.75 over 2. And the polar moment of inertia of the smaller shaft is going to be pi over 32 times 0.75 to the fourth power. That's already in pound inches. This is in inches. This is inches to the fourth power. So from this, we can find what that value of K can be. So that, again, the most stress we have anywhere in the shaft is going to be the 12,000 psi. Going through these steps, we get 1.4 to be the value of K that we can have, to not exceed the 12,000 psi. Right, knowing what the value of K can be, how can we use this to find the minimum radius we need our fillet to be?
Find D over D and then see where it intersects on the chart at 1.4.
Right, so we know the K value is 1.4. We're going to read the chart in kind of the opposite way we did in some of our previous problems. We know the stress concentration factor. We want to find that value of R here. So what we need, because this chart has multiple lines on it, first we have to determine which line that is. Right, so it's a simple calculation, but it's 2 is that ratio. Right, so going to the closest value here, if we follow this down, we get 0.1 we'll use as that ratio of R over D. Found the correct line by big D over little d was 2. We followed K over to 1.4, so we know that the ratio of R to D had to be 0.1. D is our smaller diameter of 0.75. So multiplying that through, the minimum radius for that fillet, 0.075 inches.